We are picking up where we left off yesterday. And we had been in lesson 6.2. We talked about dot product of vectors. Okay, how to multiply two vectors. So you might want to review that so you don't forget it. And then the formula we did most recently was angle between two vectors. Next topic, and we've got just a little statement about it here, but then we'll talk about it on the next page, is how to know if two vectors are considered orthogonal. See, I already can't pronounce it. Orthogonal. Okay, now, with that, notice what it says. Vectors are considered orthogonal, which has almost the same meaning as perpendicular. So we talk about vectors being orthogonal. We're basically saying, are the vectors perpendicular? If they're, what does it say? Dot products equal 0. Okay, so if dot products equal 0, then that's kind of a proof that two vectors are orthogonal. Or in other words, perpendicular, which basically means they form a 90-degree angle. Yes, perpendicular. That was my brief review of perpendicular. You know it though, right? There's a lot of big kind of look at me like, but
I was going to say a plus sign, a cross.
I know, it's like it just depends on.
Okay, so yes, a plus sign, a cross, but mathematically, they intersect at a right angle. There we go. Okay, so top of the next page. Example 4. Prove that vectors u, which is 2, 3, and vector v, which is negative 6, 4, are orthogonal. Thoughts?
Let's do the dot products and just see what it takes us.
Okay.
We're just getting that back.
And the question is, or the statement is prove, yes? So if these vectors are orthogonal, what should be true? Their dot product should equal 0. So that's what we're checking. Does their dot product equal 0? Anytime you see that word orthogonal, think dot product 0. So that means I'm going to try u dot v. How do I do u dot v?
U1, U2, V1, V2.
u1, v1 plus u2, v2. Okay. So the idea then in this case, it's going to be, what am I doing?
2 times negative 6.
2 times negative 6 plus 3 times 4. Do the math. And what do we get? We got 0.
That's all we have
So what does that tell us?
to do. Orthogonal.
Orthogonal.
Okay. So they are orthogonal. Okay, that is the proof. Okay, it asks you to prove something. There's your proof. We just showed that the dot product equals 0. Now, I'm going to do a picture because I can. Right? You're not surprised. It's me. If we look at this picture, okay, 2, 3. So there's vector u, negative 6, 4. Not number this very well. There's vector v. What do you think? Do they look orthogonal? Or in other words, do they look like they form a perpendicular angle? That looks pretty right angle-ish to me. Okay? So, with that in mind, that's kind of our check. Okay? Okay. One more topic. Because as I said, we're just going through vector projection with this lesson. I'm not talking about work and force right now. Okay? Sorry to disappoint. Okay. A vector is projected onto another vector by dropping a perpendicular vector from one vector to the other. To find the projection of u onto v, we use the formula projection of u onto v, which is u dot v divided by absolute value of v squared times v. Okay, so first of all, we have a formula, yes? And that's what I thought. Okay, the notation on this formula, I was trying to remember here. The notation on this formula, first of all, not the best idea, but it's kind of script u and v, which makes it hard to read. But notation-wise, if this is projection of u onto v, then the notation here should be projection of its big U subscript v, if I recall correctly. Yes. And if you ask me, the typed one looks like it's backwards. That's a personal opinion. This looks like the U and V are switched. So it should be capital or U there and V there. Okay. And that is based on projection of U onto V. We're going to be using this formula. Okay. Now, let's see. Do I want to draw a picture now? I think I will. And in order to draw this picture, we're going to go up here because I have some empty space, right? Trying to use my empty space where I can.
Will it take this entire?
I take up a lot of space, a lot of this space, yes, which is why I'm not going down there. Now, I will say, like example 6, I'm not doing right now, and I don't have current plans to come back to it. Not that that couldn't change, but you know. So the idea that I want to express here is what it means to drop a vector's project onto another vector by dropping a perpendicular vector from one to the other. And so the idea here, we're talking about projection of u onto v. So if I draw this as vector v, and this is vector u. Okay? The idea here, and I don't know that I have the best picture because I always struggle to draw this, but the idea is if we're dropping u onto v for a projection, and notice it says dropping a perpendicular vector from one to the other, so perpendicularly, okay, trying to get this a right angle there, then the idea is that this right here is the projection and what we usually call u1. Okay? Huh? No.
No.
I'm sorry.
You gotta get the corny jokes in, though. Okay. At least I know he's listening. Okay. So that's the visual of what we're doing here. Okay? The key is to work with the formula. So, example 5. We're going to use the idea of vector projection. And it says find the vector projection of u onto v. So we're going to start there. Then it asks us to write u as a sum of two orthogonal vectors, one of which is the projection. Okay, one step at a time here. Okay, don't worry about the second statement. Let's find the vector projection of u onto v. Sound like a plan? Mm-hmm. So, in order to do the vector projection of u onto v, we're going to use this formula. Okay. And this vector projection, what we're going to be finding, notice what I called it up here when we're projecting u onto v. I'm going to go ahead and call this u1, okay? And that's doing the projection of u onto v. And it's going to be using this formula that I mentioned earlier, u dot v divided by absolute value of v squared times v. Now I'm ready to fill in the formula. Okay, u dot v. What are you guys doing for u dot v?
Just
How do we do u dot v?
6 times 5. Then plus 2 times 5.
Yes, you guys with her? u dot v, u1 times v1 plus u2 times v2, right? So 6 times 5 plus 2 times negative 5 will be our numerator. Denominator. How do I do absolute value of v squared? So let's ask, how do I do absolute value of v?
The square root of v1, v2 plus v2.
Almost there. Yes, square root.
The square root of 6 squared v times v. Oh wait, it's just, never mind, it's just v. So 5 squared plus.
Oh, the squares.
Okay.
That's what I forgot.
I know, that's why I said you're almost there. You had the right idea in your mind. So the absolute value of v, length, magnitude, right, is the square root of v1 squared plus v2 squared. And then what are we supposed to be doing with this? We're squaring it. So we're going to square the square root, right? And then the other piece it says is times v, right? Times v afterwards. V is the vector. I'm going to put that in later because right now I've got a mess to simplify. So let me get this mess cleaned up and then I'll put the times v in on my next step if that's okay. Or go ahead and put it in right now. It's fine. There's a lot going on here. So if I clean up, what do you know about that numerator?
30 plus negative 10, which is 20.
Okay, 30 plus negative 10, which is what? 20. There we go. Sorry. Glitch in my brain for a moment. Square root of 5 squared plus negative 5 squared, and then quantity squared.
50.
Right? 25 plus 25, 50. Square root of 50 squared.
Oh.
Takes us to 50. So officially we have 20 over 50 times v. What do you know about 20 over 50?
Reduces to 2 over 5.
It's 2 over 5. Now, times v. What is v?
5.
It is the vector 5, negative 5. How do I multiply 2/5 times the vector 5, negative 5?
Distribute.
Distribute. What is 2/5 times 5?
2.
2. What is 2/5 times negative 5?
Negative 2.
Negative 2. What is this I just found?
The vector projection.
Okay, this is a projection of u onto v. It is what I termed u1. And that was the first part of what this problem asked us to do. Okay. What else are we asked to do? Write u as a sum of 2 orthogonal vectors. Okay. As we look at this, it's asking us to write u, which we have u, yes, as a sum of 2 orthogonal vectors. Sorry, started to say the wrong word there. With that in mind, okay, we know u, we know u1. Because what is u1? u1 is a projection of u onto v. Okay, so u1 is half of that answer. u1 is one of the orthogonal vectors. Now, if they want us to write this as a sum of 2 orthogonal vectors, think with me here. That means we want to take u and we want to write it as u1 plus, guess what I'm going to call the other one?
U2.
u2. Okay? Noah's withholding his comments back there. Okay. Now, so that's the statement we want to write, is that u is equal to u1 plus u2. We know u1. Do we know U2? No.
How do you find it?
What'd you say, Hannah? Okay. In order to find U2, we can do U minus U1, correct? Basic algebra there, right? In order to find U2, you do U minus U1. Do we have that information to do that? Well, most certainly. U, which is 6, 2, minus U1, which is 2, negative 2. 6, comma 2 minus 2, comma negative 2.
6 minus 2. That's
6
right.
times 2.
6 times.
No.
Okay, then I don't know.
It was 6 minus 2, and then 2 plus 2.
6 minus 2 is
3.
4.
Who said 3?
2 minus negative 2.
4. I'm not doing that one.
Just
Oh,
goes
I
to
wrote-
show.
I even wrote 3 down.
Just goes to show how one suggested wrong answer just spreads. Just goes to show. What is this a mistake here? Okay. What is this 4, 4? This is U2. We're supposed to be writing U as a sum of 2 orthogonal vectors. We know U2. We also know
You won.
U1. Are you seeing where I'm going with this?
Stop critics.
I want to write U as a sum of 2 orthogonal vectors. So I'm going to write U as U1 plus U2. So just fill in the pieces. U1 is 2, negative 2, plus U2 is 4, 4. If you do the math and check, guess what those two vectors add up to be?
6,
6, 2. The math is a little rough today.
The math is not math.
The math is not mathy. Okay,
Let's go to a different one now.
and that's where we're stopping. Okay, cool. Your homework is on page 464,
We have work time.
1 through 18, and 23 through 26.
It's like unheard of. So we never.
I've been in this class all year. I know.
Well, you look great.
And homework is due
Tomorrow.
tomorrow.
Today.
Tomorrow.